Section 5.4, Partial Fractions. Decomposition of rational expressions. We do have a rational expressions, and then we could add it up, get the LCD, and then combining two rational expressions into one rational expressions. Right? This is what we learned from the previous chapters. And then now, we want to do the opposite way. We want to do the partial fraction decomposition. Means I'm going to give you guys these rational expressions. And then I want you guys to break it up into two parts like this. Okay, and we call this is a partial fraction decomposition. We do have a different case. Case 1, the denominator is a product of distinct linear factors. When you have the rational expression pre-x over qx, we're going to look at the denominator. If the qx, we could do the linear factor. Okay, linear means we do have a first degree, and first degree. Then we're going to let a1 with the first factor, a2 will be the second factor, and so on. Depends on how many factors do you guys have. Okay, so this is going to be the case 1 when your denominator has the linear factors. Let's try to do the example 1. Find the partial fraction decomposition of this term here. We do have a one rational expressions. Let's look at the denominator. This is going to be your qx. And let's try to factor out the denominator. Okay, you should get x minus 4 and x plus 2. Okay, on the denominator, we do have a linear factor. This is a first degree, this is a first degree. So what we're going to do? We're going to let a over x minus 4 plus b over x plus 2. Okay, right? We try to break it down this guy. Now, we want to find it out what is your a and what is the b here. So first, let's find the LCD. LCD will be x minus 4 and x plus 2. So means that I'm going to multiply x plus 2 here, multiply x plus 2 here. And this guy, we're going to multiply x minus 4 and x minus 4. Okay, now we're going to look at the numerator. The denominator will be exactly the same thing, right? Let's only look at the numerator here. Now, we do have a two method to find it out. What is your a, what is your b? Method 1, compare the coefficients. So on the left hand side, we have a 1x plus 14. On the right hand side, we try to rewrite it, and then we're going to compare the coefficient. So we're going to distribute the a and then distribute the b here. And then we're going to factor out the x. We're going to group these two guys together, and these two guys going to be together. Now, we want to compare the coefficient. The coefficient of x, that will be 1 equal to a plus b. And then the constant, 14 will be equal to 2a minus 4b. Now we do have a two equation and two variable. So this one, we're gonna use the substitution. So a equal to 1 minus b. Okay, we subtract b for both sides. Now we're gonna plug in back into this equation. Okay, distribute the 2. So I got 14 equal to 2 minus 2b minus 4b. Combine the 9 terms. Divided by negative 6 for both sides. You're going to find it out. B equal to negative 2. And then we're going to plug in back to here. So you're going to get a equal to 3. So put it back to here. A will be equal to 3 and b equal to negative 2. Okay, so we just did the partial fraction decomposition. You could double check your work by finding the LCD and then multiply it, combine it together to see if you can get back the original question. Okay, and we only use the method 1 for here. Now, we're gonna redo this part and then we're gonna use the method 2. Okay, we're gonna start it from here. Method 2, we could input the value of x. Okay, so think about it. In this example here, we could plug in x equal to -2. Okay, plug in x equal to -2, plug in x equal to -2. Because when I plug in x equal to -2, this guy will become 0. So the a is going to be goes away. Okay. Then you're going to get b equal to -2. And then one more. We know what is your b here. So now we want to find your a. So think about it. Try to plug in the x, and then you're going to make this guy equal to 0. You could put x equal to 4, right? So plug it in. You're going to get a equal to 3. Okay, this is going to be the method 2. Okay, you can use both method, or you could either pick up one method. I think method 2 will be easier, okay? But sometimes when you have compared the coefficient, it will be easier to use the method 1. So it really depends on the questions. Okay, so this is the case 1 when your qx has a linear factor. Case 2, the denominator is a product of linear factor, some of which are repeated. Okay, so your rational expression, that will be px over qx. And your qx this time, that will be ax plus b to the power of k. Okay, in this case, we're gonna let a1 over ax plus b, a2 over ax plus b squared. Okay, we're gonna add 1 on it. It depends on your k. If k equal to 3, then you're gonna add a3 over ax plus b to the power 3. For example, now my qx, this is the linear factor, but it's repeated. Okay, so we're gonna let a over the first degree x minus 3, b x minus 3 squared, and then c x minus 3 to the cube. Okay, now we're gonna get the LCD. Okay, LCD will be this guy. Okay, so multiply x minus 3 squared here, multiply x minus 3 for this guy. Now, we try to solve your A, B, and C. So before we start working on the I will use the method 2. I'm gonna plug in the x value. So in here, it will be easier when I plug in x equal to 3, right? Plug in x equal to 3. So 3 squared minus 4 times 3 plus 7. And these two guys is gonna be goes away. That will become 0. Okay, so c equal to 4. And then, think about it. I also can use the method 1 at the same time. I can compare the coefficient of x squared. So I only have this term, that is the x squared, right? This is going to be the bx, this is only c here. So think about it. If I distribute this guy, that will be ax squared, and then something, something, something here. I could compare the coefficient of x squared only. So a will be equal to 1. Okay, right? So I got the a and then I got the c. Now I need to find the b here. Okay, so let's plug it in first. A equal to 1 and then c equal to 4. Now I'm gonna plug in one more value to find out the b here. I can plug in x equal to 3, right? This is what we're looking for. So I may plug in x equal to 2. Okay, so plug in here. There'll be 2 squared minus x plus 7. And this is 2 minus 3 and 2 minus 3. Okay, simplify it. You're gonna get b equal to 2. Okay, so put it back to the original one here. So A, B, and C here. Case 3, the denominator has irreducible quadratic factors, none of which is repeated. So this time, my qx, my denominator, contains the quadratic factor ax squared plus bx plus c, which can't be factored further. Okay, we can't factor out. So what we're gonna do, we're gonna let ax plus b over the quadratic factor here. Okay, ax plus b on the top. Okay, look at this one. This is gonna be combined the case 1 and also the case 3, right? I do have the linear factor here, and this guy, this is not factorable. Okay, so we're gonna let it, first one, use the case 1. That will be a over x plus 4. And then this part, this is a quadratic factor and it's not factorable. So we're gonna let bx plus c over x squared plus 1. Now, get the same denominator. Okay, and then we're gonna plug in x equal to -4. Okay, plug it in. You should find out a equal to 5. And then we plug in a equal to 5. One more. This time we're gonna let x equal to 0. Okay, x equal to 0, I could get out of this guy. So plug in x equal to 0. You're gonna find it out c equal to -2. Okay, you could plug in here again. C equal to -2. And then this time, I'm gonna plug in x equal to 1. Okay, you could pick an easy number. X equal to 1. Simplify it. You're gonna get b equal to 3. Okay, and then plug in back to the original one. Okay, this is a with the linear factor, and this is a quadratic factor and it's not factorable. So that's why we let the bx plus c. Okay, case 4. The denominator has repeated irreducible quadratic factor. So this time, my qx, they do have a quadratic factor, and also it's going to be repeated. So this is kind of combine the case 2 and case 3, right? The case 2 is going to be the factor is repeated, and in case 3, we do have a quadratic factor, and it's not factorable. Okay, so what we're gonna do, we're gonna let ax plus b over the first degree of the quadratic, and then a2x plus b2 over quadratic function over the quadratic function with the square, and then add on it. Let's look at this example. So first, we do have an x, that will be the case 1, so we have a over x. And then we do have a quadratic factor, the factor is repeated. So we're gonna let bx plus c over x squared plus 2 with the first degree. And then dx plus e over x squared plus 2 and then square. Okay, the first one, case 1, a over x. And then bx plus c, that will be the case 3. And then this one, the factor is repeated. So we're gonna use the case 2 here. Okay, get the same denominator here, and then we only look at the numerator. So first, I'm gonna plug in x equal to 0. Okay, plug it in. You're gonna get a equal to 1. Okay, this question is pretty long. So a equal to 1. And then you can keep plug in the number here, but we do have a 1, 2, 3, 4 variables. So this time I will try to distribute it and then compare the coefficient for each term. And then compare the coefficient for each term. Okay, we're gonna distribute this guy, use the a plus b squared. So a squared plus 2ab plus b squared. And then I just distribute the x, okay? And then distribute the x in here also. And then use the FOIL method, distribute one by one. Okay, once you're done, you're gonna factor out x fourth. You do have a 1 plus b here. x3 is only c here. And then x squared, we have a 1, 2, 3. Okay, factor out the x squared. Now we're gonna compare the coefficient with the left hand side. So x to the power 4th, you could have a 1 plus b equal to 1. So b equal to 0. And then c, that will be equal to 3. And then this guy equal to the coefficient of x squared, which is gonna be 4. And then you know b is a 0, so d equal to 0. And then 2c plus e equal to 2. And then you know c equal to 3, so plug it in. You should get e equal to negative 4. Okay, once you're done, you're gonna put it back. Okay, case 5. If px over qx is not a proper fraction, means the degree of the numerator is larger than the degree of the denominator. We use long division to divide px by the qx. Okay? Like this example, you could see the numerator of the degree is gonna be larger than the degree of the denominator. This is 4, this is 2. So we're gonna use the division, long division, to divide it. Okay, after you divide it, you should get your quotient plus the remainder over the divisor. And then we just need to break up with this guy. Okay, try this example. We do have a degree 3 here, and this is a degree 2. So first, we're gonna find the quotient. We're gonna use the long division. And then write it out. So that will be this guy equal to the quotient plus remainder over the divisor. And then we only need to do the partial fraction decomposition for this guy. And this one, first, the denominator, we could factor out this guy. Alright, we factor out the x, and then left with x minus 1. And then we're gonna use the case 1, right? We're gonna make it equal to a over x plus b over x minus 1. Get the same denominator. We're gonna plug in x equal to 0. Okay, so you should get a equal to 4. And then we're gonna plug in x equal to 1. Okay, you should get b equal to 3. So that will be your final answer. Okay, 3x plus a, which is gonna be 4 over x plus 3 over x minus 1. That's it.